Hi, this is Albert Ang, and this is my circuit instructional video. I'll start off with introducing the separate components of the circuit. The first thing you should know about circuits is the batteries. Batteries are commonly known as storage cells, but in physics they simply provide voltage. Voltage is defined by electric potential energy per unit of charge, which is measured in joules per coulomb. There are also components called resistors, which basically resist current and ultimately control voltages and current in the circuit. Resistance is the ratio of the voltage applied to the electric current which flows through it. The specific unit of measure is in ohms. Resistivity is more of an internal property of a material, and it is directly proportional to the total resistance R. Now, with knowledge of the separate parts of the circuit, we can move on to learn how to solve different circuits problems. A circuit problem can be organized into three parts: series, parallel, and combination circuits. For series circuits, the current is the same in every resistor. This current is equal to that in the battery. The sum of the voltage drops across the individual resistors is equal to the voltage rating of the battery. The overall resistance of the collection of resistors is equal to the sum of the individual resistance values. For parallel circuits, the voltage drop is the same across each parallel branch. The sum of the current in each individual branch is equal to the current outside the branches. The equivalent or overall resistance of the collection of resistors is given by the equation. Kirchhoff's law states that the sum of the currents coming into a junction is equal to the sum leaving the junction. This is applicable for complicated circuits, as you just need to combine the methods for finding series and parallel circuits. So now I'm going to solve a portion of the warm-up we did today on the whiteboard. This is the problem, and I'll be finding total resistance of the parallel circuit right here. I wrote the equations for the series and parallel circuits out here. For series, you can just find the total resistance by adding up each separate resistance like so. For parallel, you can find total resistance by doing 1 over the reciprocals, the sum of the reciprocals of each resistance, like this. In order to solve this problem, you need to combine B and C and D and E. So using the parallel equation for the total resistance, I found B and C to be 100 over 3 and D and E to be 100. After this, you can combine it with A like this. And in the end, you get 500 over 21. I like to think of circuits with this analogy. When you're walking through a crowded room, if everyone is moving rather than standing still, it tends to take longer to make your way across. Likewise, resistance increases with temperature for a wire, but does it in terms of movement of the ionic lattice rather than the electrons.